so when last we left here, we were looking at the compounds or the elements that were the odd one out, and we discovered that sand was SiO2, so that makes it, because it is made of two different elements. Thank you. Because it is made of two different elements, it is a compound. And of course, I've been abbreviating compound as CMPD. And that means that the rest of them are all elements because they only have one element. Even Br2, which has two Br atoms stuck together, is an element. There are many different materials in this world, but if we go to a very, very round number, there's only around 100 different elements. The number is actually closer to 120, but 100's close enough, all right? It's a nice round number. These elements can be combined in many different ways in order to make thousands or even millions of different compounds. Yes. Now, if we look at some pure elements, here we have a bucket made of copper, we have some charcoal made of carbon, and we have a balloon filled with helium. What do you notice about the atoms in each sample? They are all the same, okay? An element is a substance made up of only one type of atom. So copper is made only of copper atoms, Cu. Carbon is made of only carbon atoms, C. And helium is made of only He atoms, helium. So those are elements. Now we're going to take a look at two things. We're going to look at molecules, but not just any old molecules. We're going to look at molecules of elements. Okay, molecules of elements. So we're still dealing with all the same type of atom. The atoms of some elements join together. Do you know what it means to join together in a chemical sense? What do they do? They bond, yes. So when the atoms of some elements join together or bond, they can make molecules. Not all elements, notice I only said some elements, okay? One of the elements that exists like this is hydrogen. Each hydrogen joins up with one other hydrogen atom to make a hydrogen molecule. So we start with a hydrogen atom. In fact, we would have to start with two hydrogen atoms. And then once they are bonded, stuck together, we get a hydrogen molecule. The formula or symbol for a hydrogen molecule is, see if you can tell your partner. Yeah, I'm hearing a lot of H2s out there. That's absolutely correct because we have, what does that little 2 tell us? That tells us the number of atoms, H atoms. All right, since the hydrogen molecule is made of 2 atoms, we're going to use the word di meaning 2, and we call it di. Because it's made of 2 atoms, we call it diatomic. Okay, because it's 2 atoms diatomic. In fact, there are several elements which are diatomic, and at some point you will learn them all, and I will give you lots of lovely memory tools or mnemonic devices to help you remember them. But for now, we're just going to mention them. Other elements such as nitrogen and oxygen and chlorine also exist as diatomic molecules. A diatomic molecule contains how many atoms? 2. So let's see if you can write the formulas for these 3 elements, nitrogen, oxygen, and chlorine. Okay, give those a try. See if you can write the formulas for those 3 elements, knowing that they are diatomic molecules. And it's okay if you don't remember the symbols, right? If you can't, that's fine. We'll just give them to you, but we'll get you a periodic table soon, okay? Nitrogen is N, but because it is diatomic, it should be N2. And where does that little number go? It has to go at the bottom of the number, not at the top. And then we have oxygen, which would be O2, and chlorine, which would be Cl2. A molecule is a group of atoms which are bonded together covalently. And we will define covalently later on, but I would like you just to see if you remember anything from grade 10 or grade 9. See if you can remember anything about covalent bonds. Chat with your neighbors and see what you remember. Does anyone remember anything about covalent compounds or covalent bonds? And it's okay if you don't. Anything anyone wants to share? Yes. They don't share atoms, they share, Yes. Okay, so when there is covalent bonding, the electrons are shared between the atoms. Okay, so the electrons are shared when we have a covalent bond. Does anyone know what types of elements are involved? What types of elements are involved in a covalent bond? Non-metals. Non-metal plus non-metal. No metals, just non-metals. Non-metal plus non-metal. Do you guys remember where the non-metals are on the periodic table? Like if you were to look up at that one, because that one's got lovely color coding, okay? You have a blue section, you have a purple section, and you have a pink section. Which one would be the non-metals? That would be the pink section, okay? So if you have things from the pink section that are joined together, those are going to be covalent bonds, okay? And when you have covalent bonds, you form a molecule. So atoms can join together to make compounds. And this occurs when two or more different elements react in a chemical reaction. The atoms don't just mix together, they actually become joined, or what's the other word for joined? Bonded in different ways to one another, and they will make a reaction, but it will also make a compound. That's why on tests I don't tend to do fill in the blanks, because there are sometimes different answers that both make sense. All right, so here we have hydrogen. Okay, and it is an element. And these are hydrogen molecules because the two atoms are stuck or bonded together. So hydrogen molecules. We have an oxygen molecule. Which is an element because both atoms are O's. They are the same as each other. And finally, we have our reaction takes place. And at the end, we end up with water. And because it is made of two different elements, both hydrogen and oxygen, it is a compound. So these are water molecules. So what you'll notice is that you will have molecules that are elements. You will have molecules that are elements, and you will also have molecules that are compounds. Okay, so molecules are not exclusively compounds or exclusively elements. You can have molecules of either one, either type. So in a chemical reaction, the atoms become joined in different ways, and this is how new compounds are formed. By the way, how many hydrogen atoms are in the reactants? The reactants are the things over here on the left-hand side of the arrow. How many hydrogen atoms in the reactants? 1, 2, 3, 4. 4 hydrogen atoms. Yes? How many hydrogen atoms in the products? 4. 1, 2, 3, 4. How many oxygen atoms in the reactants? 1, 2, and in the products, 1, 2. And we're going to spend an entire unit doing chemical reactions, and one of the things that you need to make sure is that when you have a reaction and it's balanced, you don't have atoms like coming in from nowhere that didn't appear in the reactants and are now in the products. And you can't have atoms disappearing. You always have to start and finish with the same number of atoms of each type. Okay? So just to summarize, a compound is a substance in which two or more different elements are bonded together. Is a lot of this review from grade 9 and 10? But it may have been a while, right? Maybe you had science in semester 1 and now it's semester 2 a year later. So I just pretend that you've not learned anything because you may have had a long time to forget. All right, molecules of compounds. So covalent compounds, those ones made of nonmetals, they exist as molecules. So here we have a glass of water. If we could zoom in on the water, we would see little water molecules which look a lot like Mickey Mouse. Water is the Mickey Mouse molecule. It's got the face, two little ears on the top, okay? The Mickey Mouse molecule. Carbon dioxide, which is what you would find in a fire extinguisher, on the other hand, is a linear molecule. Now, if you just look at one of these water molecules, what would you write for the formula for that molecule? You have H and you have two H's, and you have O and you only have a single O. If we don't have a subscript, how many of that type of atom do we have? Just one. So one oxygen atom. Carbon dioxide, again, you can look at the molecule and you can say, what would I write for the formula for carbon dioxide? CO2, we have one carbon, so we don't put a subscript with it because if there's no subscript, it's just one. And then we have O2 because there are 1, 2 oxygens. Okay? So I've written it in the wrong place again. I have a tendency to do that. H2O, CO2. Nice. Yes? Good question. Normally, it sort of goes left to right on the periodic table. So you would start with things like H is further to the left than oxygen, and carbon is further to the left than oxygen. So you sort of go from left to right. Okay? You can also tell, like water is not a good example because water just has a name that's non-descriptive of what's in it. You can also tell from the name, carbon is named first and the dioxide comes second. Okay, so you'll either usually be given a formula or you'll be given a name and that will let you know what order to go in. There's actually a better reason than that, but we're not going to probably have time to learn about it this year, so I'll just leave that be. Okay, if you're interested, ask me later. Okay. Crystal lattices. Ooh, this is a new one. So we had covalent compounds that were made of nonmetals and nonmetals. Now we have another type of compound. This is an ionic compound. And an ionic compound is made of a metal plus a nonmetal. And I'm going to draw like a really simple diagram of the periodic table. I'm not going to make it fancy. I'm just going to make it a rectangle. And I'm going to draw a little staircase. Which ones are the metals and which ones are the non-metals? The ones on the left are the metals. And the ones on the right are the non-metals. Is it a great diagram? No, it's not, but it gives you the general area on the periodic table, okay? Now these ionic compounds, they exist as a three-dimensional crystal. And in fact, I have a little three-dimensional model here, okay? Does this look like the molecules that we saw before, like a little Mickey Mouse H2O or a little linear COO or OCO? No, it doesn't. This could actually be, 4 times as big, right? Or it could be 200 times as big, or it could be 1,000,000 times as big. This is a crystal. You know how salt is crystalline? Look at, the little salt on the table, it's a little crystal. This is what you're seeing, okay, but just really, really far away. This one we're seeing really, really close up. So it alternates. The sodium is green. Did I do that wrong? No, the sodium is silver, okay, because it's a metal. And then chlorine is a greenish gas when it's on its own. It's not green, obviously, in sodium chloride. You've seen sodium chloride. It's table salt. It looks white, okay? But it alternates sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride. And they alternate positive, negative, positive, negative, positive, negative, positive, negative. Do you remember what we call atoms that have either a positive or negative charge? See if you can recall that with your neighbor. Have a little chat. Atoms that have a positive or negative charge are called something. Starts with an I. Pardon me? Ions. Ions. Okay, so we have a three-dimensional crystal consisting of alternating positive and negative ions. So it goes metal, non-metal, metal, non-metal, metal, non-metal. And this 3D crystal is called a crystal lattice. L-A-T-T-I-C-E, lattice. Now, it's really nice if we can draw, it's really nice if someone will provide us with this lovely three-dimensional model. And some of you are probably capable of drawing that because you are very skilled. However, even if you're capable of doing it, it would probably take you a fair amount of time, yes? So instead of when we draw these, instead of drawing the full 3 dimensions, we will often just draw it in 2 dimensions instead, which requires us to draw circles instead of spheres, and to just do them like alternating in 2 dimensions instead of in 3 dimensions, okay? So this here would be our Na+, the sodium ion. And this here would be the Cl-, the chloride ion. This crystal lattice, not a molecule. One of the reasons it's not a molecule is, can you have a big salt crystal? Like if you were to, you know, dissolve some salt and then have it grow, could you grow a larger crystal than the little ones that come out of your salt shaker? Yeah, you could, okay? I actually have a crystal here. It's not a salt crystal, or well, it is a salt crystal, but it's not sodium chloride. This one is copper sulfate. That is a single crystal of copper sulfate, and it's that lovely blue color because it's copper 2 sulfate. The copper has a 2+ charge. Copper 2+ ion is blue. Okay, that is a single crystal. So you can have very big crystals or you can have very small crystals. Molecules, on the other hand, always have a specific size. Water is always just H2O. There's always 2 hydrogens and 1 oxygen. There's never like 100 hydrogens and 50 oxygens. Doesn't happen, okay? But we could have this particular crystal here, which has 8 sodiums, and it has 8 chlorides. But we could have a bigger crystal over on the left that has, oh my God, okay, let's count them. 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6. So 6 by 7 by 6 is 6 by 7 by 6 equals divided by 2 equals, so there are 126 sodiums in there and 126 chlorides. Okay, in this crystal, there's 126 sodiums and there are 126 chlorides. Would it make sense then for this crystal to write the formula as Na126 Cl126? And then this one over here, would it make sense to write it as Na8 Cl8? And then every different salt crystal you have would have like a different number of ions, and you'd have to write a different number every time. Does that make sense to do it that way? No, it would be crazy. And how would you even know? I mean, here I can count them because they're big, but if you look at this, can you count the ions in this crystal? Can you see the ions in this crystal? No, they're just far too small. Okay, so instead, when we're dealing with a crystal lattice, because the crystal can be big or the crystal can be small, when we write the formula for these ionic compounds, instead of trying to give exact numbers, we use the smallest whole number ratio between the atoms. And it doesn't matter how big my crystal is, it will always be alternating sodium chloride, sodium chloride, sodium chloride. So for every 1 sodium, there is always how many chlorides? 1. So it's a 1-to-1 ratio. In sodium chloride, there's 1 sodium for every 1 chloride. So we simply write the formula as NaCl, no subscripts, which means 1 of each. Is good? Okay. This is where I got to with my other class. the other day. So we're going to stop at this point, and I'm going to let you know what we're going to be doing for the rest of the class. Okay, so the first thing we're going to do is you are going to brainstorm with your neighbor and the people around you a vocabulary list, not just from this section, but from all the stuff we've done. Once you have done that, we'll get together and create a class list, okay? The second thing you're going to do is once we have a class list, you are going to start creating a visual dictionary for yourself. And a visual dictionary would include the word, it would include the definition. And what did we learn last day that is a really effective tool for learning? Drawing. So you're also going to draw a picture. So each word is going to have a word, a definition, and a picture. Now let's say you totally understand the meaning of a word. Do you need to do this for that word? No. You are going to choose the words from our master list that you feel you need help either understanding or remembering. Does that make sense? So you're going to choose the words that you're not 100% sure of at this point. If you're 100% sure of it, don't do it. Okay? Now, I imagine that this is one of these tasks because I'm not going to check your homework and I'm not going to make you do this, that a lot of people might go home and be like, well, that sounds like something I can put off till right before the test. Yes? I know how you think, okay? It's the same way I think when I have to write reference letters for students. Very often those reference letters are due on midnight of January 1st. Guess what I do with my New Year's Eve? I'm writing reference letters. Oh shoot, why did I not do this beforehand? Okay, I know how you think, don't leave it till the last minute. Okay, we all want to, don't do it. Start your visual dictionary today. Okay, and then the third thing, which should actually be number 2, I'm gonna put this as number 3. The reason I'm putting this one as number 2 is because I want to check your work before you go so that I know that you know how to count sig figs and I know that you know how to identify the uncertain digit before your quiz tomorrow. So that's going to be page 99. But before we do any of this right now, we are going to, with your partner, brainstorm a vocab list and then we'll talk about it together as a class. Okay? If you need paper, there is paper at the back in the free paper bin. I'll get you started with a word or two. So I've started you off with a couple words just to give you some ideas. carry on from there. See how many words you can get. Help yourself to paper. There's lots at the back. ever and ever and ever and ever and ever. I'm so sorry, I should have said that earlier. You do not need to know all the equipment. Oh, okay, so the home part is the same, right? So we have, and home is the same, right? So homogenious, I'm not sure what you means, but it means that the mixture is the same. So if you were to look at your zygote is a cell that forms when the egg and the sperm. Okay, so in that zygote you have that mom. So if you have, for let's say, zygote, okay, the brown eyes for mom and brown eyes for dad, that is homozygous. Yeah, that's biology. Yeah, and then if you have blue eyed gene and the brown eyed gene, heterozygous, but still that could fit. Yeah, it was there somewhere. All right, how are you doing with your list? You have 7 words. Wow. Hmm. Okay. So I'm going to let you know that my other clock we came up with, there were about 30 people in the class, we came up with more than 30 words. So if you have about 7 words, you're punching low. You're not punching up yet. Okay? Yeah. Also try to use now have you highlighted or circled your why don't we take a look at some of these? Okay? So I'm going to use these words more. So we have 1, 2, 3, 4, 5, 6. Yes. Yeah. So your last digit is always the answer. So all the certain digits, 1, 0, 0, 4, 3, those are all certain. The last digit is uncertain. Okay, and so the 7 is uncertain. Yeah? So here, you have 2 6s. That's correct because there's no decimal place. So they're not. Out of those two, we have a certain one, uncertain. So your second one here, zeros on the left. Or zeros on the left. Or any zeros on the left. Any zeros on the left. They're placeholders. So all 3 of them are placeholders. Okay? So Your placeholder, you're correct. Now, this one on the right, if there is a decimal, so there are four sigmas, and that zero is the that's your answer. Just to be on the safe side. Time do we have left? We got like 10 minutes? 9 minutes. Well, we better come up with our list, hey? Yes? Let's go around the classroom and get one word from everybody. If you have had all your words used up by the time we get to the end, then that's okay. You can just tell me all your words have been used up. All right, let's start with Minnie. What do you have for me? Pardon me? Okay, that's okay. Dayun. Solvent, excellent. Jilly. Soluble. Elijah. Covalent. Timmond. Element. Mixture, wonderful. Danica. Homogeneous. Also pronounced homogeneous, either way is fine. Homogeneous or homogeneous. Yuri. Sorry? Graduated. Sorry. Graduated. Thank you very much. And Sasha. Sorry? Scientific error, excellent. Julia. Overbar. Marina. Heterogeneous. Sonia. Calibrated. Zeneb. Ionic. Michaela. Bonded. Hayden. Precision. Precision, precision. Andrew. Covalent bond. Ethan. Yours are all up there? Okay, that's all right. Bryden? Same thing. Lance? Volumetric. Yeah, it's okay. By the time we get to the back row, it's a little harder because all the good ones have been taken, right? All right, Daniel. Valent. Sorry? How do you spell it? What letter does it start with? V? Valence? Valent. Like that? We haven't talked about that yet. No. All right, Max. Scientific notation, yes. Owen. Sorry? Oh, is this taken? Okay, Carly. Diatomic. Isaiah. Mantissa. Oh, dang, love it. One of my favorite words ever. Does anyone have any that have not been said already? Accuracy, yes. Any others? Yes. Mnemonic device. Not a chemistry word, but a good word all the same. Yes. Pardon me? Overbar. Oh, I think we had overbar. Yeah, we did. But it was hidden way up there, so. Yes. Sig figs. Yes. Solution. Yes. Density. Volume. We could go through all our quantities, couldn't we? Protons and electrons. Yes. Compound. I think we had compound. Did we have compound? Oh, we didn't. Compound. Yes, we need compound. Yeah. Sorry? Ion. So we are fast running out of time, so your homework is to start on, I'm hoping that my team will pop up here, is to start on your vocab list. I will actually I'm going to make a master list from all 3 classes and I will post it there after school, okay, on the homework. So you're going to start your visual dictionary. You are also going to study for the counting figs quiz, doing page 99 in our workbook, and then the Hebden is optional. You now have that book. Take it home and leave it there, okay? Quiz tomorrow, counting sig figs. And tomorrow we will go over the accuracy and precision quiz. So if you're wanting to redo it, you might want to wait until after we've done that unless you're absolutely sure what you did wrong, okay? Max. Thank you. We'll see you next day. But I am going to go over it in class. So if you want to wait till after that, either tomorrow after school or you can do it.
There's retake for tomorrow quiz, right?
Oh, yes. Oh, yeah.
Like just only one?
No, there's more than one. I have at least 2 versions more, and I can make another one if I need to.
Oh, so the question.
So the questions are all different, right? Every time you do it, different numbers. low-tech solution for a high-tech problem.
Oh, I see. You know, makes sense.
And they actually do, somebody gave me a special glove, but I'm not quite sure what I've done with it. And it just has like these two fingers,
Oh, I see.
which is really clever, but I don't know what I've done with it. Like I've put it somewhere, right? Yeah. Hi. Okay, cool. Yeah. Yeah. By the way, if there's another class that needs more,
Yeah, they probably they said there was like a lot
in the morning block.
I think they're-
So honestly, so there's a lot of your tutors in the morning block.
Yeah, yeah, yeah.
Okay. Okay. Yeah. So yeah. Yeah. Cool. Excellent. Thank you. I'm too tired to teach one more block.